I wanted to show you some of the things that have been useful to me. We'll talk about basically about the program in general, and then most of the presentation will be examples. It's an open source project. Its main executables are FFmpeg, and that's for converting video and audio, FFprobe, getting the characteristics of media files, containers, and streams, and FFserver, which streams video and audio. You can also incorporate FFmpeg into your own projects. They'll give you native executables, so .so and .dll files. It runs on all three major platforms, Windows, Linux, and OS X. That's it for the introduction, and all the rest will be examples. It's pretty common. You might want to extract the audio from a video file. In this case, we could extract an MP3 from an MP4 file. So on the command line, you'd specify FFmpeg-I, and then your input file, which in this case is the video file, and then your output file. There's no corresponding -O like there is -I. Anything on the command line that is not interpreted as an option or an input file is considered the output file. In this case, the audio is transcoded from AAC format in the input file to an MP3 format in the output file. And I'm going to start introducing some of the terminology that's used with FFmpeg and containers and streams in general. So technically, the imagine.mp4 first was demuxed into its video stream and its audio stream. And then the video stream was dropped. The audio stream is then decoded from an AAC format, and then it's put through a filter, which encodes it into an MP3 format, and then it's muxed back into the container format of MP3. It's good to know these terms like containers and streams and formats because it comes up a lot on the command line.
Hey Tim, does it come with its own audio codecs?
Like hundreds of them. If you're interested, I've got the output of all the audio codecs that it supports and the video codecs and containers and formats. So this is just a really simple first example. A couple times on the previous slide, I mentioned that I knew the audio stream was in AAC format. So how do you know that the audio stream was in AAC format? You can use FFprobe for these kinds of queries. It has a lot of the same command line syntax as FFmpeg. They share a lot of the same options. So you can call FFprobe-I and then your input. And here's the relevant output from that command. It tells you your container information up here at the top, that the container was detected to be of type MP4 or M4A. Those are synonymous. It tells you the duration of the input file, its bit rate, and then we get down into the streams, the video stream and the audio stream. The video stream is in an H.264 format with 1280 by 720 size per frame. Audio stream is in an AAC format. So that's how I knew in the previous example the audio stream was in the AAC format. Something else to get used to with FFmpeg is the way that streams are identified. So it says stream #0:0 and stream #0:1. What this means is the 0 means the first file, 0 and 1 are the stream numbers within the input file. That becomes relevant because you have to identify what you want to do with particular streams or particular input files. Some other things to notice about the audio stream is that the sampling rate is 44 kilohertz. And as a preview, we can have more than one input file on the command line. So another thing you might want to do is just copy a stream out of an existing video file. A common thing to do is copy the audio out of a video file. In the previous example, we transcoded the audio stream out of a video file. We went from an AAC format to an MP3 format. You might want to just copy it because, well, you could introduce losses by converting from one audio stream format to another, and you just want a copy, so a copy can be a whole lot faster. This is how you could just extract an exact copy of the audio out of a video file. As with the previous examples, the input file is specified with the -I option, and then VN means video and none, or drop the video. We don't care about the audio. C means codec. A means qualify it to the audio stream only. Copy is the codec. So we're saying we want to copy the audio out of the video, and what this results in is just a bitwise copy out of the video input file. This results in a very, very fast rip of the video file to an audio. It's a bit of a misnomer because nothing is being encoded, really. It's just a bit-for-bit copy. You may want to reduce a media file size because it's too big to put on your storage or to stream. So one way you can do this with audio is to reduce the bit rate. So again, we specify the input file with -I, AB 96K. A means audio, B means bit rate, and 96K means 96 kilobits per second. Why that's relevant is because there's a couple different ways that you can specify numbers to FFmpeg. A lowercase k means bits per second. An uppercase K or uppercase M means bytes. And then you can also slip in an I, which means use 1024 instead of 1000. Since we're decoding the audio, we have to re-encode it. And so this is much slower than just a rip of the audio stream. It's much slower than using the copy codec. The output file name determines what kind of codec will be used. You'll see come into play in a couple more examples. Bit rate, bit depth, and sampling rate sometimes are confusing to people. So if you imagine bringing up this audio stream in something like Audacity, where you can see the time amplitude plot, your bit depth would be the number of possible values on the vertical axis. Your sampling rate would be the time between samples on the horizontal axis. And then the bit rate is the combination of bit depth and sampling rate. So effectively, we're changing the bit depth because FFmpeg won't change the sampling rate. So you may have a long video clip from which you want to extract a certain clip, a short clip from a long clip. So you can use this kind of a command line syntax to get a short clip out of a long clip. So in this case, I had a Blink 182 Las Vegas concert, and the song I Miss You starts at 13 minutes and 38 seconds into the concert and goes for 2 minutes, we'll say. The -SS says, for the input, only start passing frames from the input to the output at 13 minutes and 38 seconds into the input. And -T is a duration. How long do you want to pass frames from the input to the output? We'll use the copy codec again, this time with a shorthand. There's no qualifier on the -C, so this is the same thing as saying copy the video, copy the audio, and that should say S for subtitles. I want to show you something about this clip, because it'll come up again. So it's completely blank at first. I don't know if you saw that. The reason for that is there's keyframes in the video, and where I specified 1338 wasn't right on a keyframe. So we picked up some difference frames, which caused the beginning of the video to be messed up, and that's called GOP, or group of pictures. Group of pictures specifies how often you get a full frame versus a difference frame. And I'll show you some ways to deal with that kind of issue, but it was a good example to...
Tim?
Yep.
Question for you. I don't know how much of that you're going to get into later on. Does that depend upon the actual input source, the video type that you have?
Yeah, it does, definitely.
So like an ABI quality versus an MPEG quality?
Yes, yep. You may want a way to quickly review a very long video. One way to do this would be to take video snapshots at a periodic rate, say once a minute or however often you need to do that. Here's a way to do it. Again, I use the same concert video file, specify the rate at which the input will be processed. That's specified in hertz. So 0.01 hertz means every 100 seconds it'll pass in frame from the input to the output, and it knows just by the .png extension how to encode that output file, and you get like a printf style string here, and D resolves to the output 1-up number of the frame. So you can get like 100 frames out of this. So go real quickly. I have all the files here, so if you want to see any particular example run, I can run it, but I figured it would be too long to run all the examples. So in a previous example, we showed how you could reduce an audio file size by reducing its bit rate. So one way that you could possibly reduce the size of a video file is by reducing its resolution, say from 1080 to 720. This example, we specified the VF option. V stands for video, F stands for we're going to do a filter on the decoded frames. The name of the filter is scale. -1 means keep the aspect ratio from the input file. And so this is width and this is height. We keep the aspect ratio from the input file, but we want the new height to be 720 pixels. This does involve re-encoding the input because in order to get those frames to put them through a filter, we have to decode the input. So if you decode it and then you change the frames, you have to re-encode it. So it will be much slower than using a copy codec. And it illustrates some defaults that FFmpeg has. I specified two files, right? The input file with the .mov extension and an output file with the .mov extension. So you may think initially that they would have the same kind of audio and video streams, but they don't. This was taken with a camcorder, which used a different kind of audio stream than FFmpeg uses as its default when you specify a .mov file on the command line. So it's kind of hidden in here that not only do we have to transcode the video frames because we performed a scale filter on them, but also it transcoded the audio frames because there's a default with FFmpeg to have the AAC format within a .mov file. We could change that to keep the original audio by specifying -C:(A) copy to use the copy codec for the audio input. Something John would like, animated GIFs. He posted to Google Plus that he hates them. So you could create an animated GIF. This is just like taking periodic snapshots. So again, we specify the rate at which to process the input. And really, so the command line is identical to taking video snapshots, except we've specified a .gif file as the output, and we didn't put any kind of printf format string within the output file. So all of the frames get put into a single animated GIF. A lot of times you want to take an audio file and replace the audio in a video file. So you want to merge a movie with a different audio stream. So here's a way that you can do that. And it's the first example of specifying two inputs to the FFmpeg command line. So we specify an audio, a revolution, MP3, and a video, my son playing soccer. We say we want to copy both the video and the audio. The shortest option says cut off the output to the shortest input. So one of these is longer than the other. The soccer is longer than the audio, so we'll just cut it off when the song ends. And again, this illustrates some defaults in FFmpeg that you need to be aware of. In this output file, we get the video from soccer and we get the audio from the song. But why didn't we get, say, the audio from my son's soccer, or why didn't we get both audios? how did it know which audio to take? There's some defaults that it uses. In this case, it's the audio with the highest sampling rate. If there's a tie, then it takes the audio that was first on the command line. There's some ways that you can get around this with, for instance, the map option if you want to override the defaults and specify which audio or video should be used in the output file. Quick way to make a ringtone for your Android phone uses the same techniques that we had done before to make any audio file. You need to make it less than 30 seconds and then copy it into SD card music ringtones. So a lot of times you have a bunch of input files and you want to concatenate them all together. This is how you can do that. Use the F option on the command line, which again means format. The format is concat, which means concatenate. Usually you have like a whole directory and you want to put these all together. So you put them in a file with this format, and specify that file on the command line, and usually you'll have a codec of copy, and it'll just concatenate them all together into one huge output file. Here's some PowerShell for when I had to do this. You don't really want to be typing this in by hand, especially if you have some programmatic sort order to do. So that PowerShell will create this file for you.
So this copy wouldn't work if you had multiple codecs? Would it just fail because you're trying to copy the same input-output?
I'm not sure, actually. I've always tried it with the same kind of streams and input files. I'm not sure how you would do that.
You'd have to transcode something.
Yeah, it would have to transcode for sure if it worked, if the -f concat even worked with inputs of different types. Okay, so I've been referring to container streams and codecs. A container is pretty much synonymous with a file format, except in the case of streaming. So a container is how you can put multiple streams, how you can store multiple streams together. For instance, video and audio or subtitles. So typically that ends up to be a file format. Streams are the media components, the video, the audio, the subtitles. Some common video streams are H.264 and MPEG-2. Some common audio streams are MP3 and AAC. Put it all together, containers are demuxed into streams, and then the streams are decoded into frames, and that's where your filtering happens. Then the filtered frames are encoded back into streams, and the streams are muxed together back into a container, which is usually a file. GOP, I mentioned before, stands for group of pictures. So in a video, every so often you get a full frame. For modern video streams, every so often you get a full frame, and then subsequent frames are some kind of differential frame, because most of the pixels in a video frame don't change from one frame to the next, so it's inefficient to keep on specifying the full frame. There's different kinds of differential frames here if you're interested, but basically the GOP specifies at what interval are those full frames included in the output. A larger GOP means a smaller file size, typically, because you're not specifying all the content all the time. But then seeking can become difficult. If you remember, when I tried to get a song out of the whole concert from a previous example, the first few frames were blank. And it's not like that in the input file. So there's some playing around that you need to do with GOP, depending on what your use case is. General tips for using FFmpeg: the order of options matters a lot. For instance, if you put the SS option on the command line in front of one input file or in front of another input file or in front of an output file, they can mean completely different things. So if you're having a problem where the command is not working like you think it should be, make sure your options are in the right place. You might want to use FFmpeg programmatically, like kick it off from another program, and you don't want all the licensing stuff to be captured. So you can use specify log level panic will make that all go away. -Y and N have to do with if you specify an output file that already exists, do you want it to overwrite automatically or never overwrite and cancel the command? You can get the help by specifying -H, and then I recommend just redirecting that to a file and looking at it in a text editor instead of the command line. Any questions?
If you wanted to use this, like included in like an app or something, what are the licensing considerations?
With certain video codecs, I think like H.264, some of the MPEG codecs, technically you have to pay a licensing fee per CPU. I think it's only like $1,000. So if you were going to use this in a production, it'd be better just pay, I would say, to pay the $1,000 for the CPU that's going to be doing your processing. But I don't know of any other licensing considerations. Definitely look at the help from -H, and then there's the best documentation is right on their website. I've really looked around a lot, and I haven't found good documentation anywhere but their website, FFmpeg.org.